Very good morning to all. This is Raghunath from Department of Mechanical Engineering, M. Kumarasamy College of Engineering. Today we will going to discuss about the engineering thermodynamics. Actually, that subject thermodynamics deals with an conversion of science from energy, conversion of heat into work, right? That basically deals with study of three E's, which are all energy, equilibrium, and entropy. What is the energy? Energy is something which causes and change to the existing atmosphere, right? We can also call it as the ability to cause changes. So humans have energy to do some work, right? Like that. It also deals with an equilibrium. What is the equilibrium? A state of balance between the two opposing forces, right? Also, it deals with an entropy, which is called as a measure or index of an unavailability. In the engineering stream, different streams have different definition about entropy. For example, peoples of chemical engineering thermodynamics have the entropy as randomness or measure of dissolvedness of the molecule. They said like that. We are at the Department of Mechanical Engineering, so we have to tell that the entropy is an index of unavailability in an index of unavailability of the system. Okay, so shall we start this session with some basic introduction, also with that scientist who majorly contributed to this subject. Because before going to study the any subject, we need to know the historical data and then what are all the laws which governs the subject is very important, right? First, I have taken the history from the Rudolf Clausius, the fundamental laws of universe which correspond to the two fundamental theories of the mechanical theory of heat, right? That are the energy of the universe is constant, the entropy of the universe tends to maximum, right? So these basic concepts are going to apply in the thermodynamics subject, right? Because what the conservation of energy principles tells us, energy of the universe is always constant, right? One form of energy is converted into other form of energy. Like that, due to an irreversibility, the entropy of the universe is always tends to maximum. Okay, natural process all occurs with the help of friction, so that friction causes an heat. This will gives an increase in entropy that will implies on the universe. Okay, so the next scientist is Lord Kelvin. What he said in its quotes, if you cannot measure it, you can't improve it, right? Like that, if you have to apply this law into your life too, because if you are spending some amount of money, if you does not take any note on it, like that also you cannot improve your savings. So he is applying on the thermodynamic systems. You need to measure how much amount of heat is given to the system, right? And then what is the efficiency of the system? We have to measure it. Then only we can improve the system's efficiency, right? The next one quote is given by the Saudi Carnot, right? The thermal agency by which mechanical effect may be obtained is the transference of heat from one body to another at a lower temperature, right? If you want to extract, if you want to make the systems to run, there will be a transfer of heat from higher source to lower source, right? So based on his principles, the gas power cycles are designed. Also the heat engines are operating based on the Saudi Carnot's principles, right? If you want to operate any device, you need two source and one source and one sink, right? The heat energy which continuously gives a source, that heat energy continuously absorbed is an sink, right? In between, we can operate a mechanical systems, right? The another one is given by Robert Boyle. God would not have made the universe as it is unless He intended us to understand it, right? So we can continue our discussion on the branch of physics, right? Thermodynamics is a subject which is in a branch of physics, right? It deals with the conversion of heat into work. Basically, that branch of physics deals with an electricity and magnetism, light and vision, sound and hearing, relativity theories, astrophysics, quantum physics, nuclear physics, condensed matter physics, heat and thermodynamics. Our main objective here is to study that heat and thermodynamics and understand the concepts clearly. And then it deals with the mechanics that we have covered in the engineering mechanics. Okay, so you should know the thermodynamics is one of the branch of physics, right? The prerequisite of this course is to you have to have a basic knowledge about the fundamental physics, right? So that heat and thermodynamics having these kind of sub branches, right? It deals with an internal energy, heat, system, and work that will give us an first law of thermodynamics, and then it will deals with also temperature scales, and thermal expansion, right? And then it is also deals with specific heat, enthalpy, phase changes, thermal equilibrium. It all comes under that zeroth law of thermodynamics. Also, the subject thermodynamics deals with an heat transfer, which are all conduction, convection, radiation, and then relative humidity, which will be covered in the psychrometry part, right? Also, these basic concepts are going to applied in the heat engines, right? Because in our practical cases, in our day-to-day life, we are using heat engines to propel the machines, right? From for the traveling of humans from one place to other place or goods, we are using automobiles, like that, planes, ships. Okay, all works under the basics of Carnot cycle. Also, these heat engines are designed basis of uh, heat engines, right? This heat engines works on these following processes, which are all operated by the first law of thermodynamics: isothermal, adiabatic, constant volume, and then how to draw the PV diagram for individual processes which is applied on the closed system. We will discuss. Okay. Also, that subject heat and heat engines deals with second law of thermodynamics, entropy. We can measure how to improve it from that entropy, and then the main basic concepts are from kinetic theory of gases, ideal gas law, equipartition of energy, and Boltzmann constant. So that subject heat and thermodynamics involves these varieties of parts. Okay, we will going to cover all the topics. Okay, the next one is, I have already told you thermodynamics is the science of energy transfer and its effect on the physical properties of the substance. So everybody having their own properties in the real life. So while studying the thermodynamics, we have to compare the thermodynamics with our real life, real world. Also, all the concepts which are applied in the thermodynamics are the part of the human bodies. Okay, so in this context, from the point of mechanical point of view, the science of energy transfer and its effect on the physical properties of the substances. So in the universe, the substances having that basic three properties, which are all pressure, volume, and temperature. So here, students, please note this point. I have started this subject with the help of the three basic properties, which are all called pressure, temperature, and then volume. Okay, after going to study that first law of thermodynamics, I will going to introduce that internal energy as a property of the system. While studying zeroth law of thermodynamics, I will going to introduce that temperature is a property of the system. Also, I will going to introduce that second law of thermodynamics, entropy is a property of the system. Okay, so you have to note that pressure, volume, and temperature. We are starting the subject with the help of these basic properties. So the energy transfer here they have mentioned as heat and work transfer. If you supply that heat to the system, what will happen? This heat will causes and changes in this properties, right? In the substance properties called, if you added that heat, what will happen? There will be an increase in pressure, increase in volume, increase in temperature due to the random motion of the molecules. So this force can be transferred to this piston, and then this piston is connected to an object which the soft, so the soft can start producing work, right? So next we can see what is heat and what is temperature. Okay, these most of the students are confusing with these two definitions because the heat is different and temperature is different. On the layman term, we all said that the heat and temperatures are equal, right? But not like that. Both the heat and temperatures are different, right? Heat is an path function, temperature is an point function. Okay, which means heat is a quantitative behavior, right? Here you can see there are two containers available in the screen. The first one container and then the second one containers, comparing to that volume, first one having the higher volume and the second one having the lower volume, but both containers are fitted with an thermometer. Both are reading same temperature, right? Here, there will not be any change in its temperature, but if you see here, there will be a drastic change in its heat content because here the higher volume liquids are there, here the lower volume liquids are there. If you want to make these liquids into make this liquid into hot, you need to supply more amount of heat to achieve this temperature. For example, in this case, if you apply lower amount of heat, that that fluids also reaches this temperature. Okay, so heat is an energy which is in transient motion where the temperature is a property of the system. How we can measure the temperature? Temperature can be measured with the help of an average kinetic energy which is possessed by an individual molecules is an temperature, right? We can say that the how fast the molecules will travel, that how fast it will hit the another molecule, so that due to this random motion and then due to this getting this kinetic energy, we can say that this is a definition of temperature, right? So definition of temperature is an average kinetic energy of the molecules is possessed by an individual molecule. That is called the definition of temperature. So the kinetic energy implies that there will be increase in temperature. In the case of heat, the energy which is in a transient motion, right? The total amount of energy which is supplied to the system. Here you can see the difference between the heat and temperature. Here, the heat of an object is the total energy of all molecular motion inside that object. So total energy of the all molecules, right? If the volume is 100 liter, the molecules are higher, they may take more amount of heat energy, right? Likewise, in the concept of temperature, it is a measure of thermal energy or average heat of the molecule in a substance. People also tells the definition of the temperature as the degree of hotness or coldness. We can also call the temperature like that. The SI unit of heat is used in a joule, where the temperature is Kelvin. In normal cases, we can use calories and Fahrenheit. Also, we are using in this subject, we are going to use symbol of heat as Q and temperature as T, right? Here you can see it is a measure of the number of atoms multiplied by the energy possessed by each atom. in the case which determines the direction in which heat will flow in the temperature. It is related to how fast the molecule within a substance are moving, right? It has the ability to work. It can be used to measure the degree of heat. Okay, the heat is used to produce some amount of work, right? Next we can see what is the need for study of thermodynamics, right? So what is the need, what is the need to study of thermodynamics, why we need to convert heat into work? So we need to design and work producing machines like engines and turbine. This will make our life very simpler and easier, because with the help of these innovations we can traveling from one place to other place and one country to other country. Also there will be a, drastic improvement in the field of aerospace. With the help of this thermodynamics, they have made all the changes what the humans need to be sophisticated. And then work observing machines like compressors and refrigerators. Okay, so we are also going to design work producing machine which will absorb heat and produce work. In the case of work observing machines, you need to supply work to the system, then system will do the work to reducing the temperature or increasing the temperature or elevating the pressure from lower level to higher level. We are also going to design and know work transfer systems like boilers and furnaces, which are going to give a large amount of heat to the work producing machine and work observing machines, right? So these boilers and furnaces are called thermal reservoirs. They may supply infinite heat capacity to the system, where the boilers will turn the liquid into phase change process will be happen in the boilers, right? Then we can see that application areas of thermodynamics, the application areas of thermodynamics are wide, which is used in the power plant, aircraft and space propulsion on automobiles, refrigeration systems, solar, which is also used in the renewable energies. The application of thermodynamics will implies huge role in wind turbines, which is called renewable energy resources, also used in air conditioning, boats, that majorly it is involved in the human body. Okay, so next we can see the basic concepts of thermodynamics. The basic concepts of thermodynamics is system, surrounding, boundary, and universe. Okay, before studying that subject, everyone should know what is meant by system, surroundings, boundary, and universe, because we need to define the system, we need to define surroundings, we need to define boundary. Okay, because there will be a transfer of energy from one transfer of energy from the one object to another object. Okay, so we need to define the surroundings and also we need to define the boundaries, whether this boundary is movable or not movable, whether this boundary is real boundary or imaginary boundary. So these cases we have to define. So friends, first we can see what is meant by system, right? System, the quantity of fixed mass, also called as system, under investigation. If you take if you take the human body as system, okay, consider I am a system, right? I am interacting with my surrounding, right? My boundaries are my skins. Okay, so there will be a heat transfer between the human body to surroundings and surrounding to human body, right? So system is a quantity of fixed mass under investigation. For example, if you take our classroom, right? In our classroom, there are 60 students. So my attention is to understand the topics which I have taught by this taught to you. So that is my attention. Okay, there are all 60 students which are present, they are considered as system, right? The surroundings are anything other than the system is called surroundings. Okay, so that campus is our surroundings and then the boundary is our classroom. classroom walls are our boundary. Okay, so in the case of real boundary, our walls, imaginary boundary will be a our college compound. Okay, so we can define the systems like that. For informal definitions, we can also tell that surrounding everything external to the system, and then the boundary interface separating the system and surrounding. This boundary may be fixed or moving boundary, right? Fixed or moving boundary. For the example of classroom, students may move from our class at any time. Okay, or the interval or lunchtime they can move. But in the case of fixed boundary, from morning to evening, they may not crosses the college compound. So that may be taken as a fixed boundary. Like that, thermodynamic systems are also having their imaginary boundary and fixed boundary. So that heat interaction and then work interaction can be happened between this system and boundary and surrounding. Okay, everything other than this, which is called as universe, the combination of system and surrounding is called universe. So because we are under the universe, okay, there will be a transfer of energy from system to surrounding, surrounding to system. So this all happens under the universe. Students, here you can see the best example of an thermodynamic system in the case of point of view of mechanical engineering. So here I have taken an piston cylinder machine which will be connected by the inlet and exhaust valves. Also there will be a piston, connecting rod and crankshafts are attached. Here you can see there are two systems are there. One is a thermodynamic system which deals with an heat transfer. Another one is a mechanical system which deals with an transfer of energy to the output system. Okay, so the boundary of thermodynamic system is the heat energy is applied on the top of the piston. How pressure or how much heat energy is effectively utilized to push the piston down. That is the boundary of thermodynamic system. In the case of mechanical system, that the connecting rod, piston, that crankshaft, all these mechanical parts are arranged under the mechanical boundary. So these walls are called as mechanical boundary. In the case of real life examples, these are all the real life example, and another one is an interesting example for system and surrounding. Here you can see the candle is glowing. So the fire which is represented here is a thermodynamic system. Here the boundary is how hot you are feeling with this candle. For example, if you places your hand nearer to that flame, so what will happen? You may feel some hotness, or you can move your heart away from that flame. What will happen? There will be a decrease in temperature. You can be able to be comfortable at that location. So the boundary can be vary. So that is called boundary. That intention of this heat energy and then the temperature which will be measured nearer to the flame, which is called an thermal boundary, also called a system boundary. And then surrounding, anything other than the system is called surrounding. So we can see this flame from 10 meters or 20 meters up to 100 up to 50 or like that. If we go to 1 kilometer, we will not able to see this flame. So this is not our surroundings, because we are going to design and work producing machines. That work producing machines need to operate on the different surroundings and different atmospheres. That atmosphere all having maximum temperature, or that atmosphere is also having that minimum temperature. For example, if your engines are going to operate in the Gulf countries, there will be a higher temperature in the surrounding. If you are going to operate in the in your engines in the Uti or Kodaikanal or Switzerland, some colder places, there will be a changes in its surrounding. So our system need to satisfy all those things, so that before studying this concept, the subject thermodynamics, we need to understand what is meant by system, surroundings, boundary, and universe. So these three interactions are happening under the universe that you should know. Okay. So next we can different types of the systems in the thermodynamics. So first we can see closed system. In this example, they have given an piston cylinder machine without valves. So that what will happen? There will be a transfer of heat and the system will produce some amount of work externally. Because what will happen? The changes in its properties will be happen with the help of this with the help of this heat. So assume in this space the air is stored. What will happen if you supply the heat? The air will expand. So during that time, the piston will move downwards. Okay, a system is said to be closed system if its mass remains constant. There will be only energy transfer to the system, right? Energy can transfer, there are no mass transfer, right? That is called closed system. System, if its mass remains fixed or constant, but there may be energy transfer into or out of the system. Okay, so that type of system is called closed system. Here you can see some of the best examples of the closed systems are tube light, human blood vessels, and engines without valves. And also we have variety of applications in the real world. For example, our refrigerator, power plant, all are operating on the steady flow devices operating in the closed cycle. There will be only energy transfer can happen. For example, if you take a refrigerator in your house, you have supplying electrical energy. That electrical energy is converted into mechanical energy in the case of in the compressor. Okay, so the compressor will transfer the pressure energy to the fluid, so the fluid can flow continuously over the condenser, expansion valve, evaporator, all those things. There will be a transfer of heat from lower level to higher level. That is only happen. So this is also one example of closed system. In tube light you can see the gases which are filled inside the tube light are glowing whenever the electrical energy passes. If you touches the tube light, due to that electrical energy passes through the gas molecules, the molecules average kinetic energy is increasing, so there will be a increase in temperature, right? So that the tube light is also emitting some amount of heat to the here some amount of heat to our room. Okay, so the work is supplied to the system, heat is rejected from the system. This is in case of closed system because the gas which is remains constant. Like that in our in our body the blood vessels are completely closed. If you see in this example, right, the energy what we are going to eat from the foods, that the energy is converted and supplied to the bloods, and it will be passes to all our body parts like hands, brains, and also knees. Okay, so we can, if we have some amount of, if we have energy, we can move from one place to other place, or else we can remain on the same place. Okay, so this is an one best example of closed system, that blood vessels. Okay, next we can see that open system. Open system, in most of the cases thermodynamic systems are open system because in the engines you can see there will be a continuously the mass is getting into the system and mass is getting out of the system. During that there will be a heat transfer and there will be a work transfer. Okay, so in the open system both energy and mass can crosses the boundary. In the case of open system both energy and mass can crosses the boundary. During that time the heat and work transfer can happen. Okay, the definition, a system is said to be open when there is mass as well as energy crosses the boundary. Okay, there are lot of examples, IC engines, also that air compressor, boilers, condensers, evaporators, expansion devices, all are comes under open system. Jet engines, rocket engines, okay, all engines are open system. Okay, another one example is human digestive system, which will give you a clear understanding of the subject because the energy transfer can happening in the human digestive system also. Okay, so we are eating some foods, it will give some calorie to our bloods. Okay, to some amount of energy, and also the remaining waste is also rejected. So in this case, both mass is also going to transfer, energy is also transfer. Okay, this is an one typical example of open system. Then we can see isolated system. In the isolated system, both mass and energy remains constant. There will not be any energy transfer or mass transfer cannot taken place from the isolated system. Okay, so we can tell a time dependent application of isolated system is a thermoflask. In our home we all having an thermoflask. Okay, if you see the thermoflask, if you pour an hot liquid to the system, to the thermoflask, it can withstand that heat up to it can withstand that heat up to few hours, like okay, 3 to 4 hours. After that there will be a there will not be the temperature will not sustained. Okay, but in the case of on the best and perfect example of isolated system is universe, because the heat transfer and work transfer can happen inside the universe. Beyond the universe nothing can happen, so that is the best example. Thermoflask is a time dependent example, and then uh, universe is an perfect example of isolated system. Both mass and energy cannot crosses the boundary, because due to we can provided that insulation, right? So after a few hours this may also lose, right? So next we can see that the systems based on the chemical composition, which are all homogeneous system and heterogeneous system. Homogeneous, a quantity of matter homogeneous throughout in chemical composition and physical structure is called a phase, or is called homogeneous system. Homogeneous, same phase, right? Uniform chemical composition, right? So water and ice cube, both having a different phase but having the uniform chemical composition. This also comes under homogeneous system. Okay, okay. Water and steam, this can also comes under the homogeneous system. Okay, in the case of heterogeneous system, a system consisting of more than one phase is known as heterogeneous system. Different phases with a different chemical composition, like that oil and water does not mix, so this can be comes under the heterogeneous system, right? Air is an homogeneous system with a varying different chemical composition, because the phase which will be remains constant. Okay, here is the difference. Mixed evenly, the homogeneous mixer is a mixed evenly, and then heterogeneous mixed unevenly. The best examples are which we have in our day-to-day applications. The petrol engine having a homogeneous mixer, wherein a diesel engine has a heterogeneous mixer, because in the carburetor there will be a mixture of air and petrol that will be mixed homogeneously. When getting into the engine, that evenly the vapor phase will be enter into the system. But in the case of diesel engines, the the high speed or the high velocity or the droplets going to be injected at the end of combustion, right? So that is called a droplet combustion. Also it is called it is a heterogeneous mixture, because of air is in the phase of gas, where the diesel that heavy diesel oil in the phase of liquid. So this liquid plus vapor is an heterogeneous mixer, right? In this case, they have given salt plus water can mix evenly. So this can be assumed as homogeneous, where water plus sand is not mixed evenly. So this is not an uniform mixer. So this is called a heterogeneous mixer. Next, we can study that equilibrium. A equilibrium is defined as a state of physical balance between the two objects. Okay, we will going to study the equilibrium in this subject. First, we can see the thermal equilibrium. What is meant by thermal equilibrium? If these two systems are maintaining the same temperature, which is called thermal equilibrium. What will happen if you place a cup of coffee over an hour? What will happen? There will be a transfer of temperature from higher temperature to lower temperature. So that is the law, right? That is a principle. Temperature can always from higher to lower. So that is a natural process. So what will happen after that? The coffee temperature is also comes to a room temperature, right? So system can maintain its thermal equilibrium over a time. Okay, if there is no change in its temperature, that is called thermal equilibrium. You can see a typical example over there are two bodies. One is a hot body, another one is a cold body, which are connected by a rod. Okay, what will happen? There will be a transfer of heat energy from higher end to lower end. Okay, first in the initial case, the cold body is maintained as 0 degrees Celsius, where the hot body is maintained as 100 degrees Celsius. So after an hour, the higher energy molecules are tends to attract the lower energy molecule or tends to move to the lower energy. So after an hour, the temperature can be equalized. Total system will be maintained as 50 degrees Celsius, or it can be up to more hours. It is remains on the same place. It can be comes to an surrounding temperature. Okay, next we can see that mechanical equilibrium, there will not be any change in its pressure, which system is called mechanical equilibrium. So they are physically maintaining its thermal equilibrium. The pressure is one example of mechanical equilibrium. Here you can see the piston cylinder, the gas is filled in the piston cylinder, right? In the case of first cylinder, right, the piston is allowed to move freely with the help of increase in gas pressure. In the case of second case, there will be some masses, there will be some weights are placed on the piston. That weights are pushing the piston downwards to the downwards. So there will be an increase in pressure in its gases. So if the state of balance between these two forces will give an mechanical equilibrium. Then we have to study that chemical equilibrium. If the molecules having that uniform chemical composition throughout the system, that system is said to be an chemical equilibrium. Okay, uniform chemical composition. So if you want to make your system under thermodynamic equilibrium, you need to satisfy these three equilibriums. You need to satisfy thermal equilibrium, you need to satisfy mechanical equilibrium, you need to satisfy chemical equilibrium. Then only we can say that the system is under thermodynamic equilibrium. Okay, so next we can study the properties, right? So what is called a property? So in real life we all having our own property, because I can also say that I have 5 acres land, I have one house, which are also the property, right? So like that, the atmospheric air also having its own property. The liquid water is having its own property. Every substances is having its own property, right? The parameter which defines the quality or condition of the system is said to be property. Okay, if an atmospheric air is maintained as some pressure of 1.0132 bar, so the pressure of an property is an pressure is a property of the air. Temperature 28 or 30 degrees Celsius are maintaining, and then volume. Okay, so due to that, pressure which is exerted on the individual molecules which are constituting the air will exert an pressure of 1 atmosphere on the earth. Okay, so we are under 1 atmospheric pressure, right? So the pressure forces acting on our human skin itself, right? Here, these in the thermodynamics, the properties can be can be broadly classified into two categories. One are intensive properties and another one is an extensive properties. So the properties whose depends on the does not depends on the mass are called intensive properties. The properties whose depends on the mass is called extensive properties. Here, students, please understand the properties which does not depend on the mass. Okay, that is called intensive property. The properties which depends on the mass is called extensive properties. The examples of intensive properties are the examples of intensive properties are temperature, pressure, density, viscosity, ratio of two specific heats, specific energy, specific enthalpy. Two extensive properties. Ratio of two extensive properties is also called uh, what is that is called intensive properties. Okay, for example, I have taken one container. Okay, so I have taken water bottle. That water bottle is having 1 liter of water. So that is under 28 degrees celsius, and also that is under uh, 1 bar pressure. Okay, so if I split this water bottle into zero point 0.5 0.5 liter, I have made a partition over a water bottle. What will happen? The volume of the bottle will change. So the 1000 ml of bottle is completely divided into two part. One is 500 ml and 500 ml, but there will not be any change in its temperature and its pressure. Okay, and its specific volume, right? And also in its density, right? So it these temperature, pressure, density, specific volumes are does not depends on the mass, where this volume, mass, total energy of the systems are called extensive properties. They are depends on the mass. The properties which depends on mass is known as extensive property. As the mass of the specimen changes, the value of extensive property will also change. It is also known as extrinsic properties. Examples are volume, enthalpy, weight. All form of energy are extensive properties. Okay, intensive properties are inherent properties. Okay, inherent properties of the humans, right? If a person sorry, uh, but if you compare to the humans, some inherent properties are does not change. Okay, but the extensive properties like house, car, bike, and then lands, that may be changed. Okay, here, and also now we can going to discuss about that energy. So what is an energy? The ability to cause some changes in the atmosphere, we have already discussed. Okay, here you can see the capacity to do any work, which is called energy, or we can say that ability to produce required effect on the system. So if you want to move your vehicle from one place to another place, you need to supply energy to the machine. So that energy can be comes from an fuel's chemical energy. If you burn a fuel, what will happen? That chemical energy of the fuel is converted into heat energy. That heat energy is converted into mechanical energy. That mechanical energy can be utilized to produce electrical energy, or utilized to produce use some turn any object, or used to produce any soft work. Okay, so when comparing to the automobiles, that heat energy is converted into mechanical energy by the rotation of the vehicle's wheel. Okay, so the forms of energy also called types of energy. There are mechanical energy. Okay, that if you rotate and soft, that will give an mechanical energy. Thermal energy in the case of heat, nuclear energy in the case of nucleus atoms, in the case of chemical energy, and then magnetic energy, ionization energy, potential energy, kinetic energy, gravitational energy, and sonic energy. So these are all the different types of energies are available in the universe. We humans, we are going to design and machine which will convert thermal energy into mechanical energy, or which will convert nuclear energy into heat energy. That heat energy is converted into mechanical energy. That mechanical energy can convert it into electrical energy or other form of energy. Okay, so these different form of energies are available. We engineers, we will going to convert that energy from one form to other form. Okay, and energy can be broadly classified into energy in storage and energy in transition. Right? Energy which in storage that can be stored in the system, and that the energy in transition can be flow from continuously one place to other place. In the form of storage, there will be two part of energy, what is mechanical and internal. Both the energies having its own kinetic and potential energy. So what is called kinetic energy and potential energy? Due to that height, right? Due to that potential height from ground level to up to one floor or second floor or 100 feet or 200 feet, we can say that the object is gaining its potential height. So the potential energy of the object is increasing, right? In the case of kinetic energy, if you throw that object from that 100 feet height, so what will happen? Due to that gravitational pull, that potential energy of the object is converted into kinetic energy. The object can travel in the fast manner. So due to that velocity, that energy is called as kinetic energy. If you see in the in the hydro power plants, okay, there are two form of energies. One are called unorganized energy and unorganized energy. So the water which will be stored on the dam, which will be stored on the dam, having an unorganized energy. So the molecules of an water is stored in the dam can move on the different directions. But in the case of organized energy, if you make an particular duct, okay, or if you make an some turbine wheel, so the fluid which will be comes in the passage will hits the turbine and produces the work and getting into the river. So what will happen, that unorganized energy is coming into that organized form. So at the time it will be comes to an organized energy. That organized energy is used to produce any mechanical energy. That mechanical energy is after that converting into other form of energy. Okay, so that is a best example of energy. So if you say that in our in our house, if you take some amount of water, right, yeah, in the vessel, okay, initially you may see the molecules which are present in the water, okay, so they does not produce any effect, right? They does not produce any work, right? If you make small hole a bottom of the vessel, right, what will happen, that unorganized molecules comes under an organized manner. If that comes under the higher velocity, you can place an wheel and convert that energy into kinetic energy and use it for other purposes. So okay, that is called, that is the basic definition and basic concepts of energy, right? We engineers, we are trying to make an unorganized energy into organized form, and and work on the mechanical systems. Okay, so energy in transition can be broadly classified into two ways. One is heat energy, another one is work energy. That heat energy is conduction, convection, and radiation, whereas work energy can be classified into soft work, flow work, and then the process can also do some amount of work. Okay, then we can see state. Present condition of the system is called state, and then the path, the line joining the two series of state points is called path. Process, when there is a change in state, then the system is said to under the process. Okay, changes in its state from one to other. And then cycle, if a system starts from a particular thermodynamic state point, undergoes a different processes, and once again comes back to its initial state point, then it's said to be under a undergo a cycle or thermodynamic cycle. Okay, assume I am in the state of Tamil Nadu. Okay, so present condition of myself is an state. We can assume this is state. Okay, so I am in the I am in the state, right? I am in the present condition. If I am moving from one place to other place, what will happen? My state is continuously moving. Okay, I am moving this place to this place, right? So the change, there will be changes in state. Okay. The path which I have followed is called path. The process, so I have going from one place to other place, so that is a process. And if I again comes to that initial state, that is called cycle. Okay, if it will be connected in this manner, that will be called cycle. Okay, so this state is connected in this manner, this will be called cycle 1 to 2, right? So point function and path function. So the graph, in the graph we can, the properties which can be easily located on the graph is called point function. Path functions are heat and work because they are energy in transition. So in the case of PV diagram, this will be a, in the case of PV diagram, this will be a work transfer. In the case of TS diagram, this will be a heat transfer. Okay, so the path followed and area under this graph is called work transfer or heat transfer. So that is called path function. Okay, so next we can see a sign convention in thermodynamics, right? In the thermodynamics, the sign convention is very important, right? If you supply heat to the system, right, that the heat is said to be positive. If you supply heat to the system, the heat is said to be positive. Here you can see 40 kilojoule of heat is added to the system, said to be positive. So the system will produce work for you. If you supply heat, the system will produce work, so the work is said to be positive. Here you can see the work is said to be positive. Likewise, if you supply work to the system, so the work is said to be negative. So the system will give heat as a rejection. So the system will reject the heat. The heat is said to be negative. Here you can see 40 joules of energy is getting into the system, and then the system is also rejecting minus 25 joules. Like in that system is also absorbing minus 4 joules. So the net heat transfer to the system is 15 joules, and the net work transfers to the system is 6 joules. If you apply the first law of thermodynamics, we can find out the total change in its internal energy of the system, which is 9 joule. Okay, which is a 9 joule, right? So the sign convection is very important. If the system, the heat is supplied to the system, the heat is positive, the system will produce an work which is an positive. If you supply work to the system, the work is negative. Likewise, system will also reject heat, that is an that is a negative part. Okay, and then reversible and irreversible process. Reversible process are imaginary process. Okay, reversible process is defined as a process that can be reversed without leaving any trace on the surrounding. For example, already I have shown you the diagram. If the system can move from this state to this state, again this can be reversed back to the say, if it follows the reverse, the same path, it can be, if it follows the same path, it can be the reversible process. Okay, reversible process are imaginary process. Okay, and all natural process are irreversible process, right? So if you imagine the reversible process, if I place my two hands like this, right, I want to make a hot feeling on my hand. What will happen? I will going to rub my hand. Now I am feeling there will be a increase in temperature on my palms. So what will happen during that shake of my two hands? What will happen due to friction? That there will be an increase in temperature. But in the case of reversible process, this will not be occur in the actual manner. There will be a the two systems are not getting into the contact. Okay, so that is called reversible process. So for our theoretical calculations, we are going to assume all the processes are reversible and apply the appropriate condition on the problems. Okay, So all actual processes are irreversible process. If you want to move from one place to another place, you need to use a road transport. So if your vehicle contacts with the road, then only your wheel good move should move. Okay. Otherwise, if you make your bike in the standing position, if you are running your bike, what will happen? There will not be any transfer of energy. Okay, but the wheel is continuously spinning. There will not be any useful because so the friction energy is needed to move from one place to other place. Okay, so that is called, if the friction is associated with the process, that process is reversible, irreversible process. If there is no friction, if there is no contact, that process is called irreversible process. Okay, so let's discuss that gas laws. Now let's we can discuss that gas laws, because before applying all the conditions to our thermodynamics, we need to know that gas laws, right? So these gas laws are given by Robert Boyle, Charles, and then Gay-Lussac and Avogadro are given that gas laws to us. So for your remembrance, you can also remember these gas laws in this way, right? Gas laws as CGBA, right? So we students, we engineering students, always we can trying to concentrate on our CGPA. Okay. So for the semesters, how your CGPA comes, you may discuss with your friends and what are all the ways to increase your CGPA. So I have make a simple assumption for these laws, which is CGBA. Okay, you can take this hint, so you can remember this. This C defines the Charles law, this G defines the Gay-Lussac law, this B is an Boyle's law, A is an Avogadro law. These are all the four fundamental gas laws. What Charles law gives us, if pressure remains constant, then volume occupied by a fixed amount of gas is directly proportional to its temperature. When there will be a mass and pressure are constant, the volume is directly proportional to temperature. What Gay-Lussac law states that the pressure of a given mass of gas varies directly with an absolute temperature when the volume is kept constant. I will give you then practical examples of these laws on the next slide. First, you can see there's definitions. If volume and mass are constant, pressure is directly proportional to temperature. That is Gay-Lussac law. If the temperature and mass are constant, pressure is inversely proportional to its volume. That is Boyle's law, right? If the number of molecules, the volume of the system is equal to the number of molecules which will be occupied on the occupied on the same volume, will give the Avogadro's law. Okay, volume is directly proportional to temperature. When pressure and masses are constant, is called Charles law. Pressure and temperature is directly proportional to temperature, which is called when volume and masses are constant, is called Gay-Lussac law. Pressure is inversely proportional to its volume when temperature and mass is constant, is Boyle's law. Okay, when the number of moles is equal to volume occupied by an substance is called Avogadro's law. The practical example of this Charles law is an carbonized and carbonated soft drink, also an vehicle tire, is an best examples of Charles law. Okay, what will happen? So both the cases, the pressures are remains constant. If you place your vehicle on the hot summer, what will happen? The temperature of the gas inside that tube will be increased. So if the temperature increases, the volume occupied by an gas which is present inside your car tire will also increase. So we may observe that the changes in its volume, will give an, so we have assumed that, so the tire pressure is reduced. Okay, there will be a gradual increase in its volume. Like that also in the container, the if you place this container in the cold temperature, what will happen? That gas which is inside the pressure, okay, so the soft drinks are having some amount of pressure, so it occupies some volume. If the temperature drops, what will happen? The volume occupied by an substances is also going to shrink right? In the case of Gay-Lussac law, the pressure cooker is the best example of Gay-Lussac law. If you see, before whistling, what will happen? There will be addition of heat from bottom. So the continuously the temperature of the substance which is present inside the cooker will increase. What will happen if the temperature increases? Pressure is also increases. The volume remains constant. The cooker volume is remains constant. During the time there will be increase in its pressure, there will be increase in its temperature, so that it is called pressure cooker. Okay, pressure is directly proportional to its temperature. Here you can see Boyle's law with the help of our bicycle pump. Okay, what will happen if you pushes this piston cylinder on the up from this handle? What will happen? The pressure of an object increases, the volume is decreased. Okay, in the piston cylinder you can apply Boyle's law. What will happen if the volume decreases? Pressure increases. If the volume increases, pressure decreases. It's an invariable with a constant temperature. Here you can see in the Avogadro's law, the number of moles which is present inside this balloon is equal to the volume which will be occupied by this balloon. Okay, these are all the some real time applications of gas laws. Okay, so next we can know that ideal gas equation, which is equal to PV is equal to nRT on mole basis, if PV is equal to mRT on mass basis. So why it is called ideal gas? Is there any gas equation is exist in the ideal gas equation like that? No, because all gases which are available in the atmosphere having their own attraction and repulsion forces. But in the case of ideal gas equation, we are going to make some assumptions. The gases are moving in the moving on the streamlined paths. Also, it is followed in the it is followed on the correct applications. Ideal gas equation is a special equation of state which is applicable to ideal gases. The molecular forces of attraction between gas molecules are zero. A gas is called perfect gas. This is not possible. This is a simplified case of an ideal gas equation. Okay. So already we have discussed that what is the temperature, right? The temperature is a measure of how hot or cold of something is, we can say like that, or a measure of kinetic energy of particles in an object, which is a type of energy associated with motion. Here you can see these molecules are having low temperature and these molecules are having higher temperature, because due to this kinetic energy, due to this translational kinetic energy, these molecules are getting energy and it is goes in the higher temperature, right? Next we can see that zeroth law of thermodynamics. If an object, right, A is in thermal equilibrium with object P, right, right, also the B is contact with the C, right, what will happen after an hour? These three are in thermal equilibrium. We can also set that நண்பனின் நண்பன் நமக்கும் நண்பன், அந்த மாதிரி நம்ம சொல்லுவோம் இல்லையா? அதே மாதிரி இங்க வந்து பாத்தீங்கன்னா zeroth law of thermodynamics. In zeroth law of thermodynamics, when a object A is in contact with B, okay, which is connected by an thermic wall, diathermic wall, that object B and C are contact with an adiabatic wall, what will happen after that? These objects can transfer its energy. Okay, these objects can transfer this energy from this, and this can transfer this energy from this. After the few hours, what will happen? These are the three objects are under in thermal equilibrium. For example, if you make an 3 cup of coffee in a container, okay, if you close this container, the first cup of coffee have a different temperature, and other cup of coffee having different temperature and different temperatures. Okay, so after a few hours, these 3 cup of coffees are comes into the same temperature. So there will be a transfer of energy from higher energy to lower energy, and then lower energy to, and then they will be equalizers with three systems. Okay, so zeroth law is a function of temperature. This is an origin. Okay, after the invention of first law, second law, only that zeroth law they have identified that the systems are going to maintain its thermal equilibrium with its surrounding. Okay, so with this I can end this session. Thank you all. Thank you for your participation. Thank you.